Of the topic Pythagoras Theorem, and here we have one more example. ABC is obtuse angle triangle, AD is perpendicular BC, and we have to prove this. Okay, to prove this, first we will find out AC square. What is AC square? From the given things we can have. From this we can clearly have AC square as AD square plus DC square. This is by Pythagoras theorem in triangle ADC. This is in triangle ADC. We can see AC square is equal to AD square plus DC square. Now this was AC square, this is AC square. Now we will change the things in left hand side. Now this is AD square plus DC square. In answer we need AB and BC and 2 BCBD. We don't need AD square. So we can substitute the value of the AD square. So AD square can be written as AB square minus DB square plus DC can be written as DB plus BC whole square. This is from the figure. DB plus BC is DC, so DC can be written as DB plus BC, and this value AB square minus DB square is from triangle ADB. ADB is also right angle triangle, so we can find out AD square as AB square minus BD square. So now this is AB square minus DB square plus, on solving this we have DB square plus BC square plus 2BC into BD, A square plus B square plus 2AB. Now DB square gets cancelled. So what is left? It is AB square plus BC square plus 2BC into BD. This was to be proved. Okay. Here we have one more example. In this question, equilateral triangle is given and we need to prove that its altitude will be this much and its area will be this much. So for that, consider the perpendicular. We draw the perpendicular. So suppose this is the triangle ABC and this is the perpendicular. So construction we have done AD perpendicular to BC. This is the construction we have done. Now it means if AD is perpendicular BC, so now we can have the proof. First we need to find out the altitude. Now look at these two triangles AB. I am talking about the triangle ABD and triangle ADC. ABD and ADC, we have AB is equal to AC because the sides are equal, and we can also have this angle as 90 degree in both the triangles, like angle ADB is equal to angle ADC is equal to 90 degree each. Then we have this AD is equal to AD as common side. So it means these two triangles, triangle ABD and ADC, are congruent. From this we can conclude that triangle ABD is congruent to triangle ADC or ACD. So these two triangles are congruent. So if these are congruent, from CPCT we can have BD is equal to CD. So BD is equal to CD. So if BD is equal to CD, so BD is equal to CD then by CPCT. And we know that this complete length was A. And BD is equal to DC. So each of them will be A by 2. So now using Pythagoras theorem in triangle, suppose ABD, we can find out AD. In triangle ABD, here I am drawing that figure again. This was A, this was B, this was D, and this is the perpendicular D. So this is A and this is A by 2. Now we can find out AD. AD square will be AB square minus BD square by Pythagoras theorem. So AD will be, on solving this we have, this is 4. So this is 3A square by 4 will be equal to AD. And after this will be the root of 3A square by 4. And it will be root 3 by 2A. So this is AD. AD is the perpendicular distance. So this is the height, or you can also say altitude of this triangle. Altitude of this triangle will be root 3 by 2 into A. We have got this value. Now we need to find out the area of the triangle. Area of the triangle is 1 by 2 base. This BC is the base. So BC is the base means A, and this is the perpendicular. So root 3 by 2 A is the perpendicular. So this is root 3 by 4 A square will be the area of this equilateral triangle. So we have to learn that area of the equilateral triangle is given by root 3 by 4 A square, and its height is equal to root 3 by 2 into A, where A is the length of the side of the equilateral triangle. Okay.